Hello, hello guys. Am I audible? Hello, am I audible? Hello, am I audible? Hello, am I audible? And is my video visible? Hello there, myself Sarang. I'm from Team BIOS. So today is the second day of the binary exploitation. So and today is the last day of the InCTF all training session. And so today I will be teaching you guys about pawn debug, red to win with arguments and shell coding. So yesterday Devi had shown you the usage of pawn debug. So basically, what is GDB? GDB is basically a debugging tool used to debug ELF applications binaries, and pawn debug is an extension on top of that, which is gonna make debugging easier for us. So I will show you how to install the pawn debug. So we'll go to the pawn debug side. So first of all, we're gonna copy the link and we're going to git clone to get the pond debug. Then we will cd into the directory, and execute the setup.sh. So since I have already installed, I'm not going to do that. So I'll show you how to debug. So this is the basic interface of the pond debug. So so why are we using pond debug? So actually, it's actually better than the normal debugger GDB, because this is actually an extension on top of it. It makes like a lot of improvements, so we can actually see stuff. So we set a break at main run. As you can see, you can see the registers, the disassembly of the main, the stack. So this is actually an like improvement to the normal GDP which you have. So we will move to the next thing. First thing, before telling you guys about red to win with args, you have seen red to win with normal red to win in the previous session taken by Devi. So first of all, we can see what is calling convention. So set of like what rules to pass the arguments into the functions. So as you can see, this sample program, printf has two arguments, the format string and the number, which you put it here. So the first argument will be stored in the RDI, in the RSI, the second in the RSI, third in the RDX, fourth in the RCX, fifth in R8, and sixth one in the R9 registers. And if there are more arguments than, like if there are more than 6 arguments, it will be stored on the stack. So uh, stack, they have explained about what stack in the previous video. Okay, so stack is basically uh, uh, basically a data structure which is like first in first out. So this is the stack where you store like return arguments. Yeah, so this is the stack, and this is the RSP, which is going to point to the top of the stack, and that'll be the thing is pointing to the first one first. Then let's do a sample program to see about the calling convention. So I'm gonna open Visual Studio Code. Include. So I'm basically doing a printf with the arguments, so you can see how the function. So I'm going to compile it with GCC. You see, it just prints out the number, the seat in GDP. We first set a break at main, and C to continue till we hit the breakpoint after running. So here you can see before calling the printf, you can see the format. This is the first argument, which points to percentage %d. RSI, or the second argument, which is the num. This is the hexadecimal representation of 1, 2, 3, 4. And yeah, that's what is about calling convention. So do you guys have any doubts about calling convention? I'll wait for a few minutes. So let's look into red to win with arguments. So you can see here the win function has two arguments which will be compared here. We'll check arg1 is equal to net code. So and arg2 is equal to code dude. So basically win function, they had told you before, like in the red to win session, you can basically return to any arbitrary function if you like overflow, do overflow and write over the return address. This is slightly advanced version since we need to have arguments for this win. So let's see that. So this is the win function. Win function here, argument 1 is check if it's equal to 0x dead core, and argument 2 is equal to 0x core dude, and you will get a shell if those match. Can you spot any bugs here? So the bug is basically in the gets function here over here. So the gets function doesn't check like the size of the buffer. This buffer is only about like 54 characters, but this gets will not check the size and can input more than 54 characters into the buffer. And let's see. we set a breakpoint at main. Here it asks for an input. We'll just put a large input. And you can see it crashed. So the first thing is we need to do normal red win and get this to the win function. So let's get, so to find offset you can use something known as cyclic in pawn debug. So you can do cyclic slash, you get 100 characters and run again. Put the thing. As you can see, it has crashed at this position. So in order to get the offset, you can just copy this and do cyclic slash L, tag L in the address. You can see the offset is 72. So now I want to use something called pawn tools, which is used for like for easily exploitation. So you can install pawn tools by going to pawn tools and going to the download pages in the here, and you can just copy this and run it on a terminal to install. And you need to make sure that you have Python installed in order for this. So on import star. So what this is going to basically do is import everything from the pawn tools library. Then we create a process, like open the binary with process, the file name which is red to win so what this is going to do is it's going to open a process and assign it to the IO. So next we, since we have the offset, let's set the offset 72. Then we're going to send so basically io.send line is used to send line to the program. So we can, and we are defining a byte string a and io.interactive. So we have connection to the shell, basically the program, so we can interact with it afterwards. Now we're going to connect with GDB. We'll provide the same file name. So it opens up in GDB. And 3. So you can see it opened up in Pond debug. Let's set breakpoint admin and continue. So basically we can see the input we have sent. In order to see more of the stack, you can use tell. This is a command used to see the memory locations. Firstly, it will default to stack, but if you give an address, it will give the contents of the address. So let's get the address of the bin function. You can use this as and get the address. And add it. So P64 is used to pack this address into a little Indian, as on the stack it's stored in little Indian format. So so the characters are actually on the stack stored right this way, first character, second, like so. So you need to be formatted into little Indian, so we use this P64. So we run it again. After the win, we can see that it it has overwritten over the return address and is now pointing to win. So let's go through the win. As you can see, that didn't work because we didn't set the arguments for the win function. If we check the disassembly, we can see it getting compared to values. So since we didn't give any arguments, it couldn't like compare, and it basically ignored the thing. So so how can we get arguments into the, for that we use something known as rope gadgets and rope chains. So it's basically it's a small like bits of code which is actually in your program, which you could use to like set so set the registers and stuff and do some things. So what is basically rope is return oriented programming. Basically we chain together with return. By return, you may ask asking, since we can control the return address, we can basically point it to whatever we want, so we can basically overwrite it and it will be easier for that. Let's see. So input, here you can see it's when you look at the stack, this is the return address. So basically when a function is called, it will first push the next instruction which needs to execute after calling the function. So since we have using gets in the program, and we can overflow this, we can basically overwrite over this stack at return address and call the main function. So we can, in order to get the rob gadgets, we use something called rob gadget slash tagged minus minus bin for specifying the binary. So these are the gadgets. So basically it's the small snippets which do stuff like pop, RDI, jump, add SP, then it will return to the next thing on the stack. So we need to set RDI and RSI for this win function. So we'll get the addresses of the pop RDI and pop RSI. So we can add that after the buffers in order to pop RDI. And we need to give the argument which needs to be popped from the stack. So that's going to be that code and code. So then pop RSI. So yeah, let's run. After returning from the main, it goes to the return gadget pop RDI. So if you see on the stack, we have this pop RDI and we have the argument. So it basically pops the argument from the stack and puts it in RDI. If you go next, you can see that RDI changed to that code. Then next we set the RSI, and since so basically this chaining happens because ret it takes the next thing on the stack and jumps to it. So it's gonna jump to the win, and it passed the check and you got it. What happened over here? So basically this move apps saying that it's not aligned to 16 bytes. So the stack, when you're calling the functions, the stack needs to be aligned by 16 bytes. So what can we do to fix this stack alignment issue? It's basically because we didn't return properly and after the calling. So we can add a ret after this, get the raw ret and add it to here, and then address. So basically what that ret does is it aligns the stack to 16 bytes. Now we pop the RDA into the from value from the stack into the RDA and RSI. Then we're gonna return to win after this red gadget. Now it will be 16 byte aligned, so we can do smoothly and open a shell. We run it without the GDB. So you can see you can get the shell. So this ROM gadget by default comes with the pawn tool, so there's no need to install anything else. So that's how you do the right to win with arguments. Do any does anyone have any doubts? I'm gonna wait for a few minutes. You can put the doubts in the chat. There's an announcement. InCTF calls will be starting on the 13th December. You can join the Discord, InCTF Discord, and open tickets if you have any doubts. So next we'll be looking at shell coding. So what is shell coding? Shell coding is basically small machine code which give you shell. Shell is basically bash which gives you control over the system. You can do whatever you want, execute commands, etc. So let's look at what syscode is. Syscode is actually like if you want to write something into the terminal, the printf under the hood calls the write syscode to write. Syscode is actually like transferring the control from user line to the kernel. The kernel is the thing that executes and prints it to the console. So let's see how we can do that. We have a challenge, try to win shellcode. So here you can see there is no win function. How we're going to get a shell now. We'll execute the we are getting some address and there is an input. Let's open it in GDB. Breakpoint at main. It's basic red to win, but there is no win. We can do a buffer overflow here because of the gets. What can we do with it? So basically you can write, as you can see, if I do vmap, which is used to show the memory map of the program. This is the mappings of the program. This is the libc. This is used for the dynamic linking part, and you can see the stack. And if you look at the permissions, you can see that it's rwx, which means it's read, write, and executable. So the stack is basically an executable. So what can you do with this? And we're also provided with some leak. If you open, so if we take this leak, and if you know, it looks like an address. So how to check where from where it is? You can use xinfo, the address, to get more info the address. So it's basically a stack leak. It's on the stack. So what you're gonna do is you can open import everything, then we debug for the debug part. Then we need to get the leak right. I'm gonna get that. We can get that by doing io.receive to get the line. Since the first line, we don't need this line, we need the second line. So we can do leak io.save line again to get the leak. So we need to first convert this in an integer. We can do that by in function and paste it. So Since it's in hexadecimal, we need to convert it from hexadecimal to int. So we're defining the standard there from which it is converting. Then you need to do dot strip to strip any new line characters with it. So what we're going to do is find the offset by doing cyclic. Then continue. You can see that it crashed here. So we can just copy it. And you can get the offset, which is at 72. And make the payload. I'm giving that much offset. And what we can do is actually to get the shell is to write over the stack. Since the stack is executed, we can return onto the stack where it starts executing the things on the stack. Since we have buffer control, we can put whatever the we want. We can try jumping onto the leak. See what happens. So okay, since I have not given the average interactive, the thing just exits. So we need to give interactive to have a shell. Keep connected to the shell. So first we'll print the stack, then we get the leak, and we for the send line. Again, use that to send the payload back. And we got the payload on the stack. As you can see, we written over the return address with the stack address, which basically points back to the stack. And do next, it returns into the stack. So we can put our shell code there. So how to write shell code? There is an inbuilt function to convert assembly shell code into bytes. Yeah, right, shell code. Triple quotes are used to make a multi-line string. So to call s is called, we need to set the arguments. So we can refer what to set and all from by searching for syscall table. X64, since it's 64-bit architecture. So you can see this is call number, which when you set in RX, this is call name, the RX value, R0 will be RDI, RSI, RDX. So we need to basically get a shell. For that, we use something known as execva, which is having a syscall number 59, and the arguments is provide is constant char file name. So basically, we point this to the /bin/sh, which is actually the shell on a system. And the RSA and the RDX, we can set it to 0. So we'll first move RSI 0, RDX 0. Now we need to set RDI to point to the string /bin/sh. How are we going to do that? We can do that by defining a string and moving, and we're going to move like load the effective address into the RDI by using plus bin sh. So basically what it does is it will first get the RIP, then add it with the bin sh. So we'll get the offset of this thing, and it'll basically return the thing stored at this location into the RDI. We'll get the bin sh into the RDI. We're not actually storing the string, but storing the address of the bin sh. And we move RX 0x3b, which is the syscall number for SQA. So let's see. We can get the bytes by using something known as ASM, which is a function which converts the shell code into the bytes. We set a break, and so this error is due because I didn't set the architecture. So in order to set the architecture, since it's a 64-bit, we need to set the architecture using context dot arc AMD64. Set a bracket main. And we can on this see that on the stack can see the sh. This is actually stored on the stack from here onwards. Now we can try jumping to this by overwriting the return address. So can do dot ljust bits, since we need to overwrite like till the offset is complete, and after that only we can jump. to the lake. This is basically the ASM. So we just pad the right side with whatever you want. You can give the offset and the bytes you want to pad it with. Um, so you can see it's jumping to the stack address, which is basically to the shellcode which you put over here. Do x/i to examine the instructions at the address. You can see move RSI, the whole shellcode over here. So we will next jumping to the shellcode which is written over on the stack. Since the stack is executable, we can execute stuff on the stack. Um, Forgot where this is called. So we can yeah, so we set the arguments rs and rdx to 0, then set the rda to the string being such, and set the syscall number 03, which is the execv, which will give you a shell. Then execute, we'll get a shell. So if you remove the debug with your process, then we got the shell now. Do anyone you guys have any doubts related to shell coding part? You can put it in the chat. If you don't have any doubts, we can see you in the qualifiers. Thank you. We are a bit late. If you have any doubts, you can watch the stream again. Uh, if you want to clarify any doubts, you can join the Discord and raise a ticket if you have any doubts.